You're welcome to FUNNYMATH page. In today's lesson, I'm going to discuss with you an interesting topic in geometry and trigonometry, which we call trigonometric functions or ratios. Let's begin. So this is a right angle triangle. This is 90 degrees. And because of that, these two angles that we see here, this angle and that of this, they're going to be less than 90 degrees. So they are acute angles. So let me call this angle theta. So when that happens, let's say something. This side, which faces the 90 degrees, is called the hypotenuse. This is the hypotenuse. These two sides that we see here, we're going to give them names right now. So before we do that, let me just give them letters. So I'm going to call here A. Here's going to be B. And this side, which is the hypotenuse, is going to be C. Let's see something. This side B, it faces the acute angle. Now this side A is adjacent to the acute angle. So you can say that A is adjacent to this because, they're in the same line or it is next to that. So we see it is adjacent to the acute angle. So here is adjacent. I'm using this shortcut for that. So that is adjacent. Here is opposite and this is the hypotenuse. But that is something that you're supposed to know. This side is not going to be opposite forever and this side is not going to be adjacent for forever. It depends on the position of the acute angle that we are talking about. Now, let me copy the same right angle triangle here and let's change the position of this acute angle and see what is going to happen to the names of this and that of that. Okay, so this is the same right angle triangle. At this time, I want to change the position of the acute angle. So I want to put it here. So here is going to be theta. At first, it was here, that is this angle, but now it is this. Now, when this happens, let's, assign the letters to the sides. So this side is going to be A, like we said in the first one. Here is going to be B, and this side is C. So let's see what's going to happen. So can you see the hypotenuse? That is always going to be C. Because C faces the 90 degrees, so that is the hypotenuse. What about the opposite? Is it still going to be this side? That is no, because it is rather A, which is opposite to the acute angle. So in this case, this side is going to be opposite. And here is going to be adjacent. You see, it is adjacent to the acute angle. So you have seen that we have just reversed the two sides. At first here was adjacent and now it is opposite here. So you have to know the difference. So it will depend on the position of the acute angle. So let's talk about the trig functions or the trig ratios. So we have the sine, the cosine, and the tangent. So these are the ratios and what they compare. Sine compares opposite to that of hypotenuse and what have you. So that is what will help you. That's the mnemonic. The SOHCAHTOA is going to help you through with the ratios or the side that they compare. Now this is the right angle triangle, and let's see this acute angle. That is theta. That's the acute angle. The side is A, B, and the side is what? C. Now if you want to find sine, the sine of this theta, so that's going to be this. Sine theta is equal to sine compares opposite and hypotenuse. So in come here, we have to know the opposite and that of the hypotenuse. How do we get the opposite? This is the acute angle, and the acute angle is opposite to this side. This side. You get it? So that's the acute angle, and it is opposite to this side. So that means the opposite is going to be B. So that's the opposite. So we have B here out of the hypotenuse. That is the easy to identify side, the side which faces the 90 degrees. So obviously it's going to be C. So that is how we can find the sine of theta from this, right angle triangle. The cos of theta or the cosine of theta is adjacent over hypotenuse. So the side which is adjacent to the acute angle is A. So in that case, it's going to be, A out of the hypotenuse, which is C. And we come here to tan theta, opposite is B, and that of adjacent is A. So that is how we can get our, trig ratios from the right angle triangle that you see here. So let's see how we can, use the trigonometric ratios or trig ratios for short. How we can use them on right angle triangles. The diagrams of right angle triangle, we have to find sine theta, cos theta, tan theta and cos theta. How do we go about this? Let's begin. You should know the acute angle that we are talking about. That's the reference angle. That is how I call it always. So this is the reference angle or the acute angle that we are talking about. That is theta. We could have used this angle, but that was not the option. This is the acute angle that we are using. Now, after knowing the acute angle, you should know the sides. This is the longer side because that is the side which is facing the 90 degrees. And because of that, this is the hypotenuse. So this side is hypotenuse. This side is adjacent to the acute angle. So here is going to be adjacent, that is adjacent. And this side is opposite to the acute angle. So that is opposite. You have to know these sides. And after knowing, you should also remember the mnemonic that is SOHCAHTOA. You have to remember SOHCAHTOA. We have to find, that is I, we have to find sine theta. So what is going to be sine theta? So sine theta, that is so, it compares opposites to that of hypotenuse. So I'm using their first three letters to stand for that. So we have opposite to that of hypotenuse. So if you are to do the substitution from the diagram, opposite is 4. So that's going to be simply 4 out of hypotenuse, which is 5. So that means that sine theta is equal to 4 out of 5. Very easy, right? Let's take the next one. The next one is talking about tan theta. Let's work that one here. So tan theta, according to the mnemonic, tan theta, that is TOA. So we have, opposite out of adjacent. So let's do the substitution. And we are going to get opposite is 4. And adjacent from the diagram is 3. So tan theta is equal to 4 out of 3. Let's take the last one. The last one here, that is I. That is talking about cos theta or the cosine of theta. That is k, right? So adjacent out of the hypotenuse. Let's do the substitution. Adjacent is 3 and the hypotenuse is 5. So that is how we can find the sine of theta, the tan of theta, and the cos of theta. From the right angle triangle, we have to find cos x. That is what we are looking for. Let's see how we can, find cos x. You should know the acute angle that we are talking about. This is the acute angle. So that's the reference angle. And cos, the cosine of x compares adjacent. So cos x is equal to adjacent over hypotenuse. That is all you have to know. But the question is, do we have the PR, which is the hypotenuse? We don't have it. For the adjacent, it has been given to be 15. So we have to work for PR in this case. So let's work it right now. And I guess, the method that we're going to use here, that is the Pythagoras theorem. We're going to use it to find PR. So let's do it. As the square of the hypotenuse, that is PR squared, is equal to the sum of the squares of the two other sides. So you have PQ squared plus QR squared. If you don't know this property, this method or this theorem, go and watch my video on the Pythagorean theory, that is unlocking the secrets of the Pythagorean theorem. I've done a video on that. You can go and watch it and you understand it. Now let's move on to it. Let's move on. So PR is what we are looking for. So still have PR squared, which is equal to PQ has been given to be 8. So that's going to be 8 squared. And QR is 15. So it's going to be 15 squared. So we have PR squared. The square root of 8 is going to be 64. And the square root of 15 is going to be 225. We are just multiplying 15 by itself. Now, PR squared, you can add this to 225 plus 64. That's going to be, 289. That is this. So 5 plus 4 is 9, 8. 289 is what we are going to get here. So what do we do next? We have to find PR by finding the square roots of both sides. So that's going to be the square root of PR squared equal to the square root of 289. So this square can cancel the square root so that we have PR equal to the square root of 289. 289 is a perfect square. Now, if you don't know, you just ask yourself which number would you multiply by itself to get 289. You can use trial and error to get it. So in this case, the answer is 17. So that means that PR is 17. Okay, so we can go ahead and find the cosine of x. That is what the question is demanding, this one. So let's do it right now here. Okay, so this implies that the cosine of x, that is given by adjacent over hypotenuse, is now equal to adjacent. Adjacent to this acute angle is 15. So you have 15 out of hypotenuse, which we just got to be 17. So the cosine of x is equal to 15 out of 17. We can't simplify 15 out of 17. So we just leave it as this. So that is how we can find the cosine of x. And angle PQS equal to x. Find A, the value of B, and B, sine x. So how do we go about this question? How do we overcome this question? You can feel free to pause the video and find the value of B. How do we find the value of B? From the information given, the perimeter has been given as 54. So P is equal to 54 centimeters. And the length has been given in a diagram. The length is 2B. That's the longest side. The width or the breadth has also been given to be B. So that the length is, twice the breadth or the width. Now, how do we use this information to find the value of B? The perimeter of a rectangle has this formula, that is 2 times the length plus 2 times the width. You have to know this formula. So now that we have this information, we can just do substitutions here. So P is equal to 54. Now, the length is 2b, so that's going to be 2 times 2b, and the width is b, so we have 2 times b. So we can just simplify to get, 2 times 2b is 4b, and 2 times b is going to be 2b. So we have 54 equal to 6b. How do we find the value of b? We just have to divide both sides by 6. So 6 goes into itself one time, it goes into 6 1. 6 goes into itself 1 and it goes into 54, 9 times. So that means b is equal to 9. That is going to be 9 centimeters. So how do we, find the next one? So we have been able to find the value of b. Let's move on to the next question. The next question, that is b. We have to find sine x. The next question, that is sine x. Before we solve the next question, this is what you have to know. The rectangle PQRS is a combination of two right triangles. We have PQS and that of QRS or QSR. So we have two right triangles coming together to form this rectangle. That is what you have to know. So let's move on to the next question, that is sine x. We know that the sine of x will compare these two sides of the right angle triangle. That is the opposite over the hypotenuse. So the question is, how do we get the opposite and that of the hypotenuse? This is the acute angle x, that's the angle. So PS is opposite to this side, and PS is the same as, QR. So that's going to be B, and that of PQ is the same as this side, SR, that's going to be 2B. That's a rectangle, so opposite sides are equal. So the next question is to find the hypotenuse, that is this length, SQ. That's the question. Since the triangles are, right angle triangles, we can use the Pythagoras theorem here to find the side SQ. So let's use that to find the side SQ, which is the same as the hypotenuse. So we can set up from triangle SQR, that is a rectangle triangle. You can use the Pythagoras theorem here, that is SQ squared, that is the hypotenuse, is equal to the sum of the squares of the two other sides. So we have QR squared plus SR squared. So we have to do substitutions here. SQ is what we are looking for. That is the hypotenuse. Is equal to QR. And from the diagram, QR is B. So we have B squared plus SR. SR is 2B squared. So we just saw that, B is 9. So that's going to be, 9 squared. And this is going to be 2 times 9 squared. That is 2 times B squared. So SQ squared is equal to the square root of 9 is 81. 2 times 9 is 18. So we have 18 squared here. So SQ squared is equal to 81 plus 18 squared is going to be what? That is 324. That's a big number, right? So we have SQ squared equal to the sum of 81 and 324 will give us 405. And 405 is not a perfect square. So this is what we're going to do. We're going to, find the root on both sides. So that's going to be s cube equal to the root of 405. But unfortunately, 405 is not a perfect square. So we can just simplify it to set form. So that's going to be, which two numbers that when you multiply, you get 405. We can take, 81 times 5. 81 times 5 will give you 405. The root of 81 is 9. So we have 9 root 5. So that means that SR is 9 root 5 centimeters. And that is our hypotenuse. So this side is, 9 root 5 centimeters. So how do we go ahead and, find the sine of x? Let's get it here. So let's continue from this side. So this implies that sine x, that is opposite over hypotenuse. So we just saw that opposite to this angle, that is x, this is the acute angle that we are talking about, is this b. So that's going to be b out of the hypotenuse. That is just what we got now, 9 root 5. Okay, so we have sine x equal to b is 9 out of 9 root 5. This can be simplified. Okay, so we can simplify this one. 9 goes into itself one time, and it goes into 9, 1 here. So that means we'll be getting 1 out of the root of 5. So that's what we have. Now we can, rationalize the denominator. The denominator is a set. We can rationalize it by multiplying the denominator by both the numerator and the denominator. So it's going to be sine x equal to 1 times the root of 5 out over the root of 5 times the root of 5, which we can simplify. 1 times the root of 5 is the root of 5 out of the root of 5 times the root of 5 is going to give us the root of 5 squared. So we can simplify this one to, the root of 5 over this square, can cancel the square root. So we have, 5 here. So that means that sine x is equal to the root of 5 out of 5. We have to find sine theta in the diagram below. How do we go about this question? Sine theta, we have to know the ratio for sine theta. For sine. Sine compares opposite and hypotenuse. So that's going to be sine theta is equal to, opposite divided by the hypotenuse. From the diagram, we have to know the opposite and that of the hypotenuse. This is the acute angle. Before we get the opposite, we have to know the acute angle. This is the acute angle that we are talking about. This is theta, the acute angle. So this side, that is BC, faces the acute angle. Okay, so how do we find the value of x? Obviously, that's going to be, to the Pythagoras theorem. So let's, state the Pythagoras theorem and use it to find, the value of x. So AB squared, that's the hypotenuse, is equal to the sum of the squares of the two other sides. So we have, AC squared plus BC squared. So AB, that is 13, so it's going to be 13 squared, equal to AC, that is 12, so we have 12 squared, plus BC, that is X. That is what we are looking for. So 13 squared is going to be, 169. And 12 squared is 144 plus X squared. We have to subtract 144 from both sides. So I'm going to get 169 minus 144 equal to, X squared. So when you subtract, we're going to get 25 equal to X squared. I have to get X, not S squared. So I have to find the roots of both sides. So I'm going to get, the root of 25 equal to the root of X squared. So that will give me the root of 25. 25 is a perfect square. So 5 times 5 will give you 25. So the answer is 5. Equal to, this square can also erase the root. So you have X. So that means X is equal to, 5. So straightforward, we can find our sine theta. So let's get that one here. Okay, so this implies that sine theta is equal to the opposite, that is the opposite over the hypotenuse. The opposite now is X, that is X, out of, the hypotenuse, that is 13. And we know that X is 5. So sine theta is equal to 5 out of 13. That is how we can find sine theta in this diagram. So this is going to be our last, question for today. We will find tan theta in a diagram. That's a diagram. Always you have to know the trig ratio that we are talking about. In this case, it is tan theta. So tan always compares, the opposite and the adjacent. So we have opposite divided by the adjacent. So that is the ratio. Now from the diagram, you have to know our opposite and that of our adjacent. This is the acute angle. So this side, AB is opposite to theta. So opposite is going to be X, and that of the adjacent is this side, BC. That is 16. So we know 16, but we don't know X. We have to find X. Let's find the value of X right now. AC squared equal to the sum of the squares of the two other sides. So AB squared plus BC squared. So AC, this is AC. X plus 8, that's a binomial. You have to put in bracket. So we have X plus 8 squared equal to AB. AB is this one, that is X. So we have X squared. BC is 16. 16 squared. We have to expand the binomial. So that's going to be, X plus 8 multiplying itself equal to X squared plus, 16 squared is going to be 256. That is 16 times 16. You have to multiply these two binomials. We just have to multiply every content in this one by everything that we have in this one. So let's do it. X times X will give us X squared. X times 8 will give me 8X. And 8 times X will give me 8X. 8 times 8 will give me 64. So I'm done with the multiplication. And that is equal to X squared plus 256. we can, simplify this side. So to get x squared, these two guys, they are like terms. 8x plus 8x will give me 16x plus 64 equal to x squared plus 256. So what you're going to do right now is we are going to group all the letters on one side. I mean, the terms with the letters on one side and the numbers to the other side. So let me group the letters on this side. So we have x squared. So I'm taking this x squared to this side so that we get minus x squared. We get it, plus 16x. And I have to take 64 to this side. So I'm going to get 256 minus 64. So x squared minus x squared, they will just erase each other. And we have 16x. When you subtract 64 from 256, we are going to get 192. So what do we do next? To find the value of x, we have to divide, both sides of the equation, of the equal to by 16. So 16 goes into itself 1, 1. And 16 goes into itself 1. And it goes into 192 12 times. That means x is equal to 12. So we can find tan theta now that we have, the value of x. So let's gather one here. Okay, so this implies that tan theta is equal to opposite, and opposite is x. So we have x on adjacent is 16. So we're going to get x, which we just got, 12. That is 12. So we have 12 out of 16. So tan theta is equal to, we can simplify 12 and 16. So 4 can go into 12 3 times and goes into 16 4 times. So we have 3 on 4. That is how we can find tan theta in a diagram. That'll be all for today. Thank you for watching.